Okay, I'm going to comment on a video I saw where Not a Professor Dave was on there. It's not understanding something that David Weiss was trying to explain to him, and he calls it like nonsense or something in here. I have some comments for this, so I had to do it this way, so we're going to have to watch it on my camera.
Let's move to stars and constellations. How do varying star constellations help us with our observations? Since we don't all own a spaceship, and we can't all go up there ourselves physically and look down ourselves, how can we, observe the constellations and stars and see that the Earth is round?
So the constellations themselves, like the way they change very slowly over time, or just the way the celestial sphere rotates?
We'll go with.
Did you hear that? Okay. So Professor Dave says that the stars rotate. Just keep that in mind.
Celestial sphere rotating.
So this is like the most obvious one of all and the easiest one to wrap your head around, and that's why I only managed to get one thing of slides out during that exchange. So this is the one I did because it's a silver bullet. In the northern hemisphere, the night sky goes counterclockwise around the north celestial pole, and in the southern hemisphere, it goes the other way, clockwise. Furthermore.
Okay. That statement it sounds true, but it's actually it's not quite true. Because if you are in the southern hemisphere and you're facing north and you're looking at the stars to the north, they will be going counterclockwise, setting in the west. So it's not a southern-northern hemisphere thing. It's the direction you're looking only.
Or when you're in the very northerly latitudes, you can't see certain stars, like the Southern Cross. When you're in the very southerly latitudes, you can't see certain stars.
Okay. When something in the sky is either going away from you or you're going away from it, it will appear to go down, down, down until it hits the horizon. And Dave here thinks that it's because the Earth's blocking it. And that's wrong too. But you can't see Polaris from very far in the southern hemisphere. It's way too far away. That's what we see when things go too far away, like the sun. There's a point at which our eye doesn't, or any optics have the ability to see smaller, to put it simple.
Like Polaris. And so the night sky is rotating different ways, right? Now.
Okay, so he's saying that it can't be a flat ground, because if we look up at the sky, I don't know what he's trying to say. He's kind of proving himself that he just doesn't understand what the sky's doing. That's what he's doing right now. He's proving that to us. From anywhere on the earth, the sky will appear to be different. If you go to different locations, the motion of the stars will appear to be different from different locations. The sky is very large. You can look north, south, east, or west. And it's basically, if you had a sphere around you, that's why he said celestial sphere. If you had a sphere around you, it would very much be 180 degrees of that sphere would be the sky, right? Whoops, we're losing our thing there. Okay. The sky itself only rotates one direction. It just depends on where you're looking and what direction you're looking. And what he's going to say about a clock, we'll get to that.
Let's move to stars and constellations.
Whoops, we got to start over, I guess.
How do varying star constellations help us with our observations, since we're not...
We'll see how far we go here. I remember I tapped the screen to get the thing off of there. Sorry, guys. We were after that, so this fast forward goes really slow, I guess. There, we'll try right here.
It goes the other way, clockwise. Furthermore, when you're in the hot, very northerly latitudes, you can't see certain stars, like the Southern Cross. When you're in the very southerly latitudes, you can't see certain stars, like Polaris. And so the night sky is rotating different ways, right? Now, on this flat pizza, you've got one guy towards the edge, one guy towards the center. They're looking up, and the sky is rotating in opposite directions. Right. How does that make an ounce of sense? It makes no sense. And Weiss tried desperately to do this thing about directionality and like, oh, if I'm facing this way.
I saw that.
Okay, this guy's like laughing at, I saw that. You guys clearly don't understand. You don't see Polaris like directly above you. You don't see the Southern Cross directly above you. That's north. If you go in anywhere in the northern hemisphere and you look north and draw a vertical line, that's where Polaris is. You'll see that star at, for me, it's at 45 degrees. If I go south, it changes. If I go north, it changes. So that's Polaris. In the southern hemisphere, they're not looking up at the Southern Cross. They're looking at it at an angle, like everybody. I'm just saying you'd have to be at the South Pole to, oops. Don't tell me it's going to make us start over again.
Let's move to stars and
Oh, this is
constellations.
bad.
How do varying star constellations...
I guess I can't do that then. I can't even do commentary, I guess. I'm gonna... Okay, so if you face south, if you go to the southern hemisphere and you face north, guess what direction the stars are going to rotate? Counterclockwise. But Dave just said they're clockwise in the southern hemisphere. Dave doesn't understand his own globe model. Okay, let's see how far we are.
And so the night sky is rotating different ways, right? Now, on this flat pizza,
Not a flat
one
pizza.
guy towards the edge, one guy towards the center. They're looking up, and the sky is rotating in opposite directions.
No, they're not looking up. They're looking north or south.
It makes no sense.
Let me pause.
Weiss tried
Okay, I can only pause it for a short
to do
amount of
this
time,
thing about
apparently.
directionality
Whoops.
and like, oh, if I'm facing...
Okay, Dave Weiss was explaining directionality because you clearly don't understand it, Dave Farina. You are condescending and to your own harm. Listen to yourself, not even understand this simple thing.
this way.
I saw that.
It's
Oh
like
my gosh.
clockwise and counterclockwise. Okay.
No, not counterclockwise and clockwise. That's the direction you're facing. If you're in the southern hemisphere, test it out. Look at the Southern Cross. It'll be going clockwise. Turn around and look to the north. You won't see Polaris, but look to the north. You'll see all the stars going anti-clockwise. They're still setting in the west. It's not like the sky changes directions, Dave. Horrible.
Put a clock on your ceiling.
It's not a clock on the ceiling. It's a clock that starts at Polaris or the south. They're all the stars are going the same direction.
Which way can you face to make the hands go counterclockwise?
Well, if you're looking at the sky isn't like a clock like that. For it to look like that, I don't know where you would have to be. I don't know where you could see the sky like that.
Which way is that, right? There's no way. It goes clockwise. It's a clock. But
No,
it's very, very, very...
Dave, it's the direction you're facing. Okay, right now, here, let me just show you where, okay. See this? We're facing south right now. The stars set in the west. Okay?
obvious on a sphere, right? If you are facing the North Pole, right, then...
Okay, Dave don't get it. I'll try to make a video. I want to make like a diagram, but I've found it difficult, and then I think about it. Maybe it's not something that we can make a diagram of. It's the heavenly realm. So anyway, Dave, you're wrong.